Okay, so we will discuss more about Hadoop. As we already discussed that Hadoop is a framework that allows for the distributed processing system whenever we have requirement for the large data and we have to process that large data, then this is a challenge that how we are going to process that. And not only processing, timing is also a issue because we are having some limit for the time. It is not that okay, you got 1 terabytes of file and you are good to process and you can process it either in 1 day, 2 day or 1 week. That is not the case. We have to process that with the limitation like maybe every hour we are getting 1 TB data or every day we are getting 1 TB data. If every hour you are getting, then your job should be able to process within that time. If you are getting daily, then on the same day before receiving the next day data, it should be finished processing the previous day or today's day data at the end of the day. So that should be there. For that, you have to think about the design how you are going to do that. So for that, we are going to take the help for the distributed system that can be any platform. And whenever we have the challenge for processing the large data sets, then we are preferring this distributed framework, which is a group of machines that we say cluster. And it is designed to scale up from the single server to thousand of machines. Thousand of machines in the sense, let's say today you have a cluster of 20 nodes because this has been set up to process some 50 terabyte of data. But from next month onwards, you are going to get double amount of data, whatever you are getting since your last 6 months. What is the requirement now? If you are going to get double amount of data, your cluster size also should be double. You need more nodes now. Then it is scalable. It can be added, it can be removed at any time. It, so it is supporting from single server and from single servers to thousand of machines or whatever as per the requirement. And this is offering local computation and storage and as per configuration, as I said yesterday, this is completely configurable and whatever you want you can do. If that is not set up, maybe that we can do by the configuration setting. We can go, we can change and we can get it. For example, this replica is having 3, but we can do even 1 also, we can do even 10 also. Either from the file level means global, and either command level for the particular file. And this allowed to process vast amount of data very efficiently and reliably. And HDFS, that means Hadoop Distributed File System, provides a scalable and fault tolerant storage, which is having the phases like MapReduce and yarn we have for processing, we have HDFS for storage systems. And this is going to support structured data, unstructured data, and semi-structured data because we have the challenges for the data also. Previously, if we just talk about last 20 years or 15 years back, then most of data were structured data. Then social media apps and multiple different apps platforms came, which is generating data in different forms. Now data is getting generated semi-structured. It was previously as well, your XML and JSON. Then unstructured data. Nowadays, unstructured data is a lot, right? So we have to process all kind of data. If we see back to the traditional system, let's either that is Teradata, Oracle, or whatever. It is good to process your structured data, but what about semi-structure? What about unstructured? Maybe some databases are there who are supporting semi-structured data as well, but unstructured, this is again a challenge. You have images, you have audio, you have video, you have to process that as well. So this Hadoop or related platform, either you are talking about any cloud and all, these all are supporting very perfectly. Okay. Here I have mentioned the comparison, simple comparison between Hadoop and traditional databases because before uh, this distribution model introduced, we all had the requirement with traditional database itself. But what was the challenges and to overcome that, we came to Hadoop side. Here, if you see the data volume, then this Hadoop is handling large scale data terabytes to petabytes, zettabytes, whatever, easily because you are having option for the clustering. You have the cluster with multiple machines. All the machines are distributing the data amongst them and they are working. If cluster is not sufficient, we have the option to add the nodes. More nodes we can add and we can do the scaling. For traditional database, this is best suited for smaller and structured data set. And again, always you can't remove and delete the networking and services from here and there like Hadoop. That okay, I need more resources, add that. I need less, remove that. You don't have that much uh, flexibility and options in the traditional database. Whatever it is, uh, since beginning with its structure and configuration and all, you have to work with that. If we talk about cost, then this is open source and runs are inexpensive hardware. So these all are open source services. So for most of the things you are going to get free license and all. These are the license. One traditional databases you have to pay a huge amount and then you are going to get it. So this typically requires expensive and high end servers. Data types support, this is supporting either structured data or you have semi structure or you have unstructured, any kind of data you are getting from the source or you are going to store at the target location. After doing the processing, you are completely fine without any challenge. You can, because lots of tech stacks are available inside the services, you can utilize that. Like in Hadoop side you have Hive for warehousing where you can uh, go with the metadata details, your structured tabular kind of data you can say, and then you can do the processing. For NoSQL kind of requirement, if you have unstructured, semi-structure and all, you can go for the HBase, and multiple other options are there. Here you don't have such option, mostly structured data, where you have to create the table in advance with row, column, even define the data types and all. And then you are going to store the data and process that, whatever you want to do. Then for data processing, this Hadoop model uses a distributed processing system with MapReduce or Spark. MapReduce yesterday we discussed, right? So this is for the processing, how this will process the data, input data based upon our business logic model we have provided. That is replaced now with Spark. We are using Spark services for processing the data, but if you are using Hadoop, even you are not writing MapReduce code, but internally it is designed as if you write any command or any SQL kind of syntax and you are running, then internally it converts the code into its Java, which is its base for the Hadoop, where it is designed, and internally it will be processing in phase of MapReduce only. First mapper will run, then it will do its own task, then reducer will be coming in the picture and it will completing the task with the map output. For the traditional one, this is sequential processing, means limited parallelism. And in Hadoop side, you have the option for parallelizing the job, and that parallelizing you can do with MapReduce and Spark. Then scalability wise, this is horizontally scaling is possible by adding the more machines. Anytime, even we can remove the machines if not required. Let's say I had 50 machines node, 50 cluster node. Now I don't need that. I need a small machine, or maybe the same cluster I want to break into the multiple parts. Okay, let's take two machine, uh, for the development, two or three for the testing, then five for the UAT, and the remaining 10 for production. I want to break that into that model, or maybe I want to make some different project wise clusters and resources. So we can add, we can remove anytime, we can change the structure. But here it is, if we talk about our traditional models for the databases and all, these are the scalings vertically and the limited hardware upgrades, because whenever we are taking, means we are doing the initialization for this, then at the very first level only we are going to have all the setups, and what we are adopting at the first, we are going to work with that only. Then fault tolerant. For fault tolerant, this is having replica model. in Hadoop side where whatever data we are submitting, this is going to replicate the data for each and everything, not for a single one. Even you were not saying to do the replica, Hadoop will do by default. And by default, replication factor is 3, but we have the control, we can control that. And that is making sure that, okay, at any case, if something goes wrong, or which is the main file, if that is missed, or it is not working fine, or it is taking lots of time, that is also having one processing option, then how it is going to recalculate the data, how it is going to recover the data to make sure that it is not losing anything. So that is helping this replica factor. And when we talk about this traditional model, then this is having limited fault tolerance. So these things are going to add a lots of complexity because completely model is changed. Schema flexibility also. If you most of you have most probably worked with the database, what happens there, you are going to, this is schema is specific, right? So you are going to define the schema, even data types. If something wrong, you are going to get up either error or maybe your data will be populated as null. Then again, that's a issue, you have to resolve that if you are finding at later point. So this is schema unwrite where strict schema defined upfront. Without that you can't do anything. And Hadoop side schema is used for the different purposes and with a different model. Here it is schema on read. So define the schema at the read time. Even without a schema, we can do the processing and multiple things. Schema is not required actually. Let's say you are working with HDFS and directly you are running your Spark with the HDFS. Schema is not required. If you are working with Hive, then yes, you have to create the schema and you have to process the data. Again, if you're going for the HBase, schema is not required. You can create a schema as per your own need with the column family. So that is flexible. This traditional model were not flexible. Real-time processing, as of now in this digital era where we are currently in the 21st century, lots of data is getting generated with varieties, with frequency, with the different qualities and all different demands are there, requirements are there. So here we need to process the data with multiple options, like some data, okay, we are good to process the historical data, that we can do with the batch. Some data we need to process in the real time. For that we need as soon as possible. Historical data we need to process because most of the companies are using historical data to understand their customer behavior, and once they know the behavior about the customer, their business, their um, different products, then they will be using that analyzed data for improving their services and serving the customer in a better way. So for that purpose, they are processing all the historical data. That data you are good to process in batch also. Okay, I am having a 1 month data or 1 year data. I am not in hurry. I can plan to process. Okay, every 1 hour I will process some amount of data, and we will be doing our analysis. Some data which is real time means as soon as coming we have to do. Let's say someone is requesting through your website, then immediately responses would be going. Someone is ordering some product from your website, immediately responses would be going, right? So different requirements are there. So these distributed models are perfectly fine with that, where we have multiple options. Like Spark is very popular, which we are going to do with PySpark in our later sessions. So this is good for either your batch or your streaming data in real time or near real time. Both options can be. Again, when we talk about traditional database, then no, this is not supporting the real time processing. It is mostly for the data which is coming from the source, it is getting stored, and then this is processing in the batch. It means kind of historical or batch, you can say, but not the real time data. Then is it transaction? This is the main part, right? If you are working with the data and if you are talking about the databases and all, then Hadoop is not designed for complex transactions. Of course, this is designed for the different purposes where your target is to store the huge amount of data, process the data with different varieties like unstructured, semi-structure, and structure and all. And this is completely designed for the structured data. So this is supporting complex transactions with the ACID properties. So if you have that kind of requirement, then traditional database is going to be the best option instead of this Hadoop. But again, you can have the mix up opportunity. You can utilize this also and this also altogether. So you can get both the options. Ecosystem wise, this is having lots of options with the distributed model, like we have Hive, Pig, HBase, and a lot. This is not limited with this only. And this traditional model is limited with the database features and its extension and not much. And use case wise, you already understand that we are either you are using for your big data processing, which we say data engineering, or analytics, or batch processing, real time processing, your data science requirement, your real time visualization, presentation, dashboard, and all, or any other kind of similar requirement. You can use these things. Traditional database is good for the transactional systems, for banking, e-commerce and all, for storing their data and doing the processing on top of that, but again, not in the real time. Okay, so this is something which is the differences. And previously, before coming to Hadoop and all, our projects were running with traditional database only. Right now, also traditional database will always be there because it is having its own benefit, own pros and cons is everywhere, right? So this is having its own advantage, and this is never going to be off. It will always be there, but with some requirement and some flexibility and what we are looking for, how we can configure that together. We are going to use that, but not completely. Our task cannot be done with traditional database as of now. If any one of you have worked on migration project, anyone, not with the database, anything?
Yes, the current project I am working on, it's a migration project.
Okay. So this is related to big data or migration with some other tool to other tool.
They are migrating the on-prem data to cloud, I mean AWS. Then from AWS, they are again migrating to Snowflake.
Okay. So that means in your on-prem, most probably data is in any of the database, right?
Yes, yes,
Yeah. So data is in database, and then they will be migrating that data to your cloud. And in cloud, either they will be storing the data in the available database of the cloud, or maybe converting to the file system and storing to the, let's say it's AWS, then it can be S3 bucket, right?
yes, yes,
So we
yes.
have different models. So like that, if you are getting opportunity to join any of the bankings and all, then their data is very important. See, let's say 10 years back, some customers were there. Maybe their account is not active, or they have closed their bank account, and anything can be there. That data is not required for the customer, but for the bank, that data is very important because they want to analyze the data since last whatever data they have available. And based upon the data, they will be getting a lot about their customers' behaviors. Let's say some bank is doing the analysis and they are getting that, okay, um, if I am talking about India, then in India, these are the list of district where I had more customer. That means in that area, people are more interested or more aware about that particular bank, right? Okay, out of 20 services, these services were more popular. People were taking interest. So, and this is the age which who are getting this kind of service. This between this age to this age, people are going for these services more, and these are the feedbacks. People are having concern about that. If we resolve this issue, then our services can be more optimized, and this can serve in a more better way. Multiple things can be there. So accordingly, this is going to work, and they are utilizing all the historical data for processing, understanding multiple things to improve their customer behavior. So they are having lots of So all the data, if we talk about where is the data, which data they have since last 10 years, 20 years, because hardly I can say that if anyone has started working with the data engineering and big data processing side, then most probably they started by 2015, 14, 15, or if someone was too early, then I can say okay, 10, 12, that's fine. But that this is not too back, right? It's just 10, 12 or 15 years back. Hardly 15 years, I will say. Otherwise, it's 10, 12 maximum you can say. You can take. Then what about the previous data? Where that is? Either they have already migrated or they will be migrating or that is in progress. It can be. Their data is in their Oracle or SQL or Teradata. Multiple services they have the data and now they are going to take utilization of the data by by migration and all. So in that case, they are going to work with the distributed model. Okay, now coming back here, if you see, here we have three views of the data. This is for the three views of the big data, which is designed to handle for volume, velocity, and variety. Variety we already discussed about the data type. So here if we talk first about the volume, then this is referring the vast amount of data being generated and stored. As we know right now what is happening, let's say take the example of YouTube. You suppose that you got hired by Google and you are getting the opportunity to work with YouTube. Then what is the challenge? It means millions and billions channels has been created. Everyone is generating the videos, right? And they are uploading, deleting, processing, modifying, and even um, um, someone is having copyright issue, someone is having a strike issue, someone is just a copying, pasting, someone is claiming something. Lots of things are there. How you are going to take up all that things? And all the things are in real time. You have to process that. So lots of volume also there, lots of variety also there, and lots of velocity also there in the same use case. And you have to tackle all the things with the time and with the quality. Both things are the demand. You should not do mistake also, and you should be on time also. It is not like that okay you are fast, you did completely in 2 seconds or 5 seconds, but output is be there or not, not good, right? We have to go with the uh, proper output. It should be bug free, it should not be having any kind of issue or errors, no mistake. So volume, it is referring the vast amount of data that is getting generated at the source, and we are going to process and then store. Then this architecture is designed in a way that it is enabling to scale across multiple machines to store and process massive data set. As you already understand, this is a group of machine. Whatever you are trying to do, this is going to distribute the data amongst them, and then it is working in a distributed manner. For example, we have social media platforms which is generating terabytes of every day. Even now I can take petabyte, not terabyte also. How people are activate and they are working, they are generating the data by messaging and all, that will be petabyte. Then velocity, describing the speed at which data is getting generated, processed and analyzed. And this distributed model is going to support the real-time data or near real-time data or data processing through the framework like Kafka, Spark, and all. Then your example can be real-time stock trading data or sensor data from the IoT devices and all. Let's say you are trading in the stock market, right? Then how it is, it matters for a millisecond also, right? If you are keep an eye on the dashboard and let's say the system is working very slow, for 5 seconds this is getting freeze, or 10 seconds this is getting freeze, and what happened during that time, maybe something too good, something too bad, then that can be beneficial for someone, that can be loss for someone, it can be. So it should be always real time, it should be up, it should be running, and it should be perfectly working. So for that kind of things, as data is getting generated very faster, and at what speed that is getting generated, at the same speed with the same time it should be processed, and it should be stored, and it should be going to the end user, so that we can do in this distributed model. Then variety wise, this is supporting the diverse data type data formats, either with the structure, semi structure, and unstructured, and it can be processed. And yes, this system is going to support with all the formats, like it can be your CSV, text, images, videos, audios, JSON, XML, and many more. If you talk about the things, then you have multimedia, you have log files, you have relational data across the different sources and all, which is going to be processed at this in the same environment at the same time. Okay. Then again, you have cap theorem. Anyone is aware about cap theorem?
Yeah.
Who is that?
Pawan.
Common?
Yeah.
Tell me about cap theorem in one line.
Like
Yeah, go ahead. Don't worry. We are not interviewing.
actually what like for the like data like continuously comings and like uh, it also like sorry you can go ahead.
No worries. No
Yeah.
worries. Okay. So this is just a model how this data is going to be trade off between the cage and the distributed model. So here you can see I have mentioned the cap. C is for consistency, A is for availability, and P is for partition tolerance. So sometimes in the interview also, you can have the discussion about this, like okay, why you are using distributed model, why you are using Hadoop, because we had already traditional database, right? Then we are jumping to Hadoop, you are jumping to Spark. Then why Spark? Why Hadoop? Why MapReduce? Why big data thing? These are the very common questions, and these questions are going to describe about your understanding. What is your understanding? Let's say you know that Hadoop works in the distributed model. Hadoop supports lots of data to be processed very quickly, but how and why? If you don't know, then somehow or somewhere we can say that okay, you do not have proper understanding. You know what it does and how it does, but you are lacking with understanding. And also these questions are just to clarify about your understanding, that okay, you are having that. So these are very common questions. Sometimes you can get this. Okay, you have the traditional database, then why you are moving to Hadoop? That means uh, person want to ask or want to understand from your end that what is the benefit you are going to get, and what were the challenges with the traditional model, traditional databases, which we were not able to process, and that for that challenges, to overcome to that challenge, we require any of the platform which is supporting, and we can overcome from those challenges. We can process the data according to the requirement, not according to the system. Okay, system is allowing that I will process in 24 hours, but my requirement is saying that no, I need in 1 hour only. So which is compatible for my requirement? How I can overcome from that? So that those are the challenges, and for that challenges we are choosing the resources, platforms, and all accordingly. Like that, you can have questions for cap theorem as well. What is cap theorem in the not in the big data only? This is a at multiple places, but this is just a way. Okay, so you should have an understanding. If that is coming to your way, you can describe it. So this is C for the consistency, A for the availability, and P for the partition tolerance. If we talk about C, then every read receives the most recent write, meaning all nodes in the system shows the same data at the same time. So this is having consistency. Then availability. Every request, either that request is for read or for write, receives a response. And even if some nodes in the systems are down, the system remains operational. That is not going to be missed. That okay, some nodes are not available, then I am having some waiting or some freezing period or systems are not working perfectly. No, that is not going to be. It is having the availability. Then partition tolerance. That is for the system continues to operate despite network partition, like failure that splits the systems into multiple isolated parts and all. So here a distributed system can only guarantee 2 out of 3 properties at the same time. You have CA consistency plus availability or CP consistency plus partition tolerance. Means you have 3, right? Out of 3 there can be 2. If you are talking about the guarantee that which can be guaranteed. So if we talk about C plus A consistency plus availability, then it is achievable in the system without partition tolerance. It can be removed at that time. If we talk about C and P, then it is ensuring consistency during network partitions but may sacrifice the availability. And if we talk about A and P, then availability and partition tolerance. That means it will be maintaining the availability during the partitions, but may lead to inconsistent data. So it can guarantee for the 2 out of 3 at any time. So anyways, it will be working with all 3, but this is just the option. That can, it has the option can, right? It can only guarantee like that. Then Hadoop generally prioritize availability and partition tolerance, as it is designed for large scale data processing and fault tolerance, though it can offer eventually consistency. So it will be having consistency, but prioritize wise, it is having availability and partition data to make sure that data is always available. And if any issues is happening for the, like, let's say some failures for the networking side or some systems, uh, in that case also this is going to operate perfectly for the partition wise. Okay. To make sure that it is having availability during the partitions, and either that is maintaining with the consistency of the data or maybe inconsistent for the data. Then we are coming to this point which we were discussing yesterday, HDFS and yarn map reduce. See, if you are trying to understand about the Hadoop system, Hadoop is a platform where we are going to utilize multiple services for data processing and all. But if you are just you assume that you have to process the data, what will be the terms? You have 2 terms. One is for storage and one is for processing. You are going to store the data, you are going to process the data. First, what you will do? First, you will store, and secondly, you will be processing. Then let's talk about the storage part first, and we will discuss about the processing later. Because first we need to store. When we are coming to storage point, then it is having a design. Okay, cluster design. Let me take you to this diagram. This one. Okay. Let's say this is a model, right? This is for HDFS. This is the name node. This is the secondary name node, and you have multiple data nodes. Data nodes are the worker nodes, actual nodes, and this is your cluster will be like you are having 10 nodes. Then one node, let's say name node. One node is the secondary name node, and remaining 8 are working as a data node. So this is your model. Now, if you are going to submit any of the data, then your actual data is going to submit here at the data node. You are going to request with the server, and that is providing you according to the space and whatever directories and all you are defining, this data will be stored. Now, when you are storing the data, then what is happening? It is going to store the data actual at that place, and then here we are. Okay, so when you are going for the storage purpose, then first it is storing the data at the data node and it is getting managed by the name node. Managed in the sense storing the metadata detail. So this HDFS is designed to store very large data sets reliably and to stream those data sets at high bandwidth to user application. Okay, you are having name node and data node. So name node are the master node and data nodes are the worker nodes, which are storing the actual data. So what happens? Let me take you to this. This is your name node. Okay, and in the same cluster, you will be having one secondary name node. Secondary name node. What we say? We say it active node, active name node, and we say this to passive name node. Passive name node, and then we have n number of data nodes. Let's say data node 1, data node 1, then data node 2, and accordingly you will be having good number of data nodes. Let's say this is going to be, and then finally data node 100. Let's say you are having 100 data nodes. You are going to store the data, you are going to process the data. Then let's say you are having a file of 1 GB. You are going to process. What will happen? This file name is test.csv. Then this data node is going to store the actual 1 GB file, and this name node is going to take the metadata of this file. Metadata in the sense, what is the name of the file? Okay, this is test.csv. What is the volume? This is the size is 1 GB. Where it is, where how many partitions are? Then okay, I am having these many partition. And how many blocks? So these many blocks. On which data node it is stored? So this is the address, data node and block address. So all these informations are captured to the name node. Now what is secondary name node then? So you are understanding that this is having the high availability concept, that one replica is storing here and one replica is storing here. So if this is down, then this will work. Then what if name node is down? Because name node is keeping all the details for the metadata and all. Then everything will be stopped, right? Because this is the master. If master is down, then how workers will work? They will also be down. So to avoid that, we have secondary name node concept. Secondary name node is just a backup of name node. They communicate with each other with some interval, and they share the data between them. So at any case, if name node is down, then immediately this secondary name node will play the role of name node, and when it will be repaired and it will be back, then it will be now getting treated as secondary name node. Means one will be active and one will be passive. So which is first available, that will be active, another will be passive, but both will be having the data sharing with each other to make sure that they are synced, and if any failure is happening, then it can take the responsibility of the main name node. So because of that, we have concept for active and passive name node. Okay. Now coming to data. So name node is only this is the master node. This entire architecture is for master and slave node, and the name node is going to maintain all the metadata details. It is maintaining the namespace hierarchy, but not the actual data. And data node is going to maintain the actual data. It will be maintaining that, and that processing also will be happening to this worker node only. Now 1 GB data you have, what will happen? By default, let's assume that your configuration for the block size is 128 MB. Means in by default, this is the size for the one part. When you are trying to submit 1 GB of file, it will be splitting that file into many parts with 128 MB. Now you tell me how many parts will be created with that 1 GB file. Anyone can tell.
Maybe 9.
1 GB divided by 128 MB.
Yes. So this will be completely 8, right?
Yeah, 8 or 9.
8 parts. And let me take it. Let's say it is 1.1 1.1 GB. Okay, or 1.5 GB. Let's assume. So okay, so let's say this will be having 8 parts. Assume that this was 1 GB equal to 1024 MB, right? 1024 MB. 1000. Assume that this file was little more. Here it will be having 8 parts. Assume that you have something. Remove the GB. 1100. In that case, 8 parts will be for 128 MB and 9th part will be for 100 MB. Remaining 100 MB, right? 100 MB, it will be having your 9th part. 9th part of the file. So you will be having total nine chunks. So as soon as you are submitting the data, this will be this will be parted based upon the block size. This is the backend block size. This block size is configured in HDFS-site.xml. We will see this when we are starting the practical tomorrow. Okay. There you can configure this size. This is editable. But this is not, as a developer point, this is not our task. These things will be under control of admin team. Okay. So let's say 9th part or 8th part based upon the file size this created. Now what will happen? This is going to create replica again. So if 9 part, then 9 into 3. 9 into 3 equal to 1027. 27 parts will be there. Parts for the file. Means 3 will be 9 will be actual and remaining 18 will be copy of the file. Okay, and these 27 will be saved to your data node. Now what happens if you have 1 GB file or 1 GB file, then output after the submission it will be having 3 GB with its replica. Okay, this is going to take 3 times. So it is going to occupy that much volume as well. So you have to take care what is the availability and what you are looking for. So because of this reason, sometimes we go for single replica if that is not that much required. But anyways, we never go with that because there can be a condition of losing the data and all. But you can go with the 2 replica also, not 3 replica. And in some critical condition, we go for 4, 5 replica as well. This is completely depending. So let's say for the 9, your actual file is having 9 parts, and for that 9 your output is again with replica. This is 27. Now how this 27 is going to be stored? So let's say 9th part. For the 9th part, this is taking first part. This is first. Again, this data node is taking second. Okay, this data node is taking third, and accordingly this is taking part 9th. 9th part is getting stored to this node. There can be a condition where this first part and second part can be at the same data node also. Not required that this is going to be stored at the different. Okay. First and second can be here. Even third also can be here. Based upon the availability, memory, size and all, it depends. Not required that all will be divided with the different node. For storing wise, it can take. Now it's a replica. because this is the actual part. One, first, second, third, fourth. We have ninth part. This is going to be stored. This can be this will be stored with the different data nodes based upon its memory availability and all. Once this is done, then it's the turn of the replica. Replica is for their high availability, that if any condition, in any condition, if that is down, let's say data part 2 is saved at data node 2. What happens if data node 2 is down for 1 hour or maybe the entire day, or it's completely failed? Then what will happen? What about the second part of the data? Because this is the part of this test CSV. If you are processing this, then you need the complete output, complete data. It can't be like you get something and it is okay. No, you have to get the entire one. So for that case, it is maintaining the replica. So for that replica, let's say this is the second copy. So second copy is having 3 replica. This is the main copy. Let's assume that this is main copy. Now this is having 2 remaining copies, 2 replica. So here on the third data node, let's say this is data node 3. Okay, on the third data node, it is storing second first copy, copy 1, and here it is storing second and copy 2. That means this was main copy, means copy 1. This is copy 2. So let me take you copy 1 and this is copy 2 and this is copy 3. These are the replica. In any case, if this is down, then this data is recoverable from this and this. Anyone can be, which is first reachable, that will be turned into the main copy, and then it will not get stopped. It is not having any issue, and that your process will be continue. It will be taking care. And when it is storing this replica, then there is a rule that 2 replica can be on the same node, but third replica at any case will not be on the same node. Let's say all 3 replica get stored at the same node. Then if that is down, the entire data will be lost, right? As I said, that multiple copies, multiple chunks or data parts can be over the same data node. That is not an issue, because this data node is having, let's say, 50 terabyte of memory availability or 1 terabyte of memory availability. Then 1 terabyte is a lot and my file is 1 GB only. It is having the most of the memory is free. Then it can store first part also, second part also, third part also. Now it is coming the time of the replica. A replica wise also, it any data node can store main copy or along with one more copy along with the main copy. Means one replica, one main copy, one replica. But all 3 copy can't be stored over the same data node. Reason is only that high availability maintenance, that if data node is down, then at least one copy should be over the separate node so it can be recovered. Otherwise, it will not be able to recover. That is further replica wise. Any issue in this? And also, if at any point, if you think that I am faster or you are not able to understand or you want to have some query, please stop me. All good?
Yes.
Yeah, ma'am.
Then later I will ask the question. Okay. If you are not asking, I will ask. Okay, fine then. So here this is for the replica one. Now the thing is, I said that if data node is down, then another copy will be treating as a main copy and your processing will not stop. But how server will understand that data node is down? That is again a question. So you have NameNode. And NameNode is the master for the server, right? Which is maintaining all the metadetails and all. As soon as you are saving your 1 GB file, then that NameNode is keeping the metadata details in the sense each and everything about the file means file information. Like this file is having 9 parts, on which data node it is, and how many replicas are there, and what is the size, and all the things. Now, this data node and name node get communication with each other on an interval of 3 seconds by default. That is again configurable, but by default this is set up as 3 seconds. So each 3 second name node will get communicated with the data node, and that we say heartbeat. Heartbeat, okay, data name node is connecting with data node, and this is getting the heartbeat. That means name node is working, data node is working very fine. There is no issue. So this will be getting heartbeat from everyone on each 3 second, and it will be considered that all good. Now let's assume that this data node 2 stopped sending any heartbeat on the first 3 seconds. Then name node will understand, okay, something wrong. Then it will wait. It will wait for 10 continuous heartbeat. That means 30 seconds. Okay. So it will wait for 1, 2, 3, 4, 10. Finally, if it did not get the heartbeat continuous 10 times, then name node will understand that, okay, something wrong with data node 2. This is not responding. That means either it's down or it failed or something happened wrong. In that case, name node will scan all the details of data node 2, because this is when this is communicating with the for the heartbeat on every 3 seconds. Then that 3 second this is getting all the details, and with that 30 seconds of the data, it is maintaining the checkpointing in the sense, okay, whatever information you have, just transfer with me. So this is getting the all the information from the data nodes with its communication checkpointing details. Okay, so as it stopped responding, in that case, the last checkpointing happened. Whatever data it got as input from the data node to this is having all the details, metadata details. It will be scanning. Okay, for the data node 2, what is the information available? So data node 2 had uh, copy means parts for this file. Okay, this has part for 1 GB test CSV as well, along with some other files, and how many these many parts were stored here. For these many parts, these were replica, and this replica belongs to this file, this replica belongs to this file. This will be having all the information. Now what name node will do? Name node will get all that information, and it will create one more copy. So let's say this data node 2 had main copy. Now this is down. So name node will understand that, okay. Now this is not available with me. Name node will having complete understanding. Now name node, what it will do? It will delete it. Means not delete, just I am deleting it. Name node will understand that, okay, this is down. What I have to do now? Name node will get some other. Okay. Here is the 4. This is the fourth one. Fourth one is having the space availability. Then name node will say, okay, data node 3rd, you have the copy of the main copy which was stored over the data node 2. Then yes, this is having the copy, right? Then it will say, okay, make it main copy. This is main copy, and now it will be copy 1. Let's assume it got converted to main copy. Now you're processing what was happening with the data node 2. Now that will transfer with this, means data will be recovered from here, and it will start from this one. So no data loss. Now name node will say that, okay, that problem got resolved. I have made this enable to work at the place of this main copy, but now I have only 2 available. This is the one replica, and this is the another replica, but main copy was down. and I have 2 copies available now. So next this also can be down. Then what will happen? I will be having only one availability. So for that name node will always try to maintain 3 replica. Name node will go to data node 4 or maybe any node. It will see where the memory or space is available. It is getting that okay. Data node 4 is having some availability. It will say okay, make a copy. Make a copy here. Copy 2 for the second one because this was down. This was previously it was for data node 2, but data node 2 is down. So it will make one more copy over the data node 4. Now again it is having 3 copy. Copy 1, copy 2, copy 3. That means if anything is down, then immediately it will make another replica copy as main copy. So your processing will not stop, nothing will impact. And next it will try to maintain the 3 replica again with some other node. So in any case, if this is also down, then you will be having 2 availability. If this is also down, then this will be having the availability. So to make sure that all good, this will be happening. Now, some concept happens for the under replica and over replica. Under replica in the sense, again, question, let me know if you are fine. If it is confusing to you, please stop me.
Replica means anytime it is maintaining 3 replica, right? So in case one node is down, and it considered as under replica. So it will create another copy into the another node to make it 3. And in case in this example only, it create a copy in node 4, right? And in the meantime, if it is getting the response from the earlier data node 2, so it is going to over replica because copy is now copy the data is available for data node. So again, it has to delete one data node to make it 3.
Correct. Your understanding is completely fine. So here what will happen? This is the having the concept of under replica, over replica, and missing replica. So under replica, over replica. Why I want you to understand these things, the companies which are completely dedicatedly working with the on-premise, they will be having such questions because they want to understand in depth. And so they will make sure that okay, you have good understanding. And I will share my recent experience. I was interviewed for TNS, that is Telecom Networking Services. I guess the complete name. That's a product-based company, and it's a very older organization. You can Google it, Google about it. So they are completely working with Hadoop as of now as well. Okay. So they had the question mostly about the Hadoop side only. In very recent 6 months back, I am talking about, and they had the question that what is means a complete architecture about the Hadoop and all. Then what is happening if any data node is down, then what is happening with the replica and all questions were around under replica, over replica, missing replica, data node health issue, how it is maintaining the copy. So the point was only that they wanted to understand about my understanding, what I understand about the servers and all, how it is getting maintained, how it is maintaining the data. So we can think about, okay, why they are asking such questions, but that is making sure that, okay, I am good with that. So that is completely evaluating over the understanding. So you can assume if anyone is having such a workload and they are having a completely dedicated server with the on-premise, then these questions not mandatory, but this can be part of your discussion. Okay, so better if you have the understanding. So under replica, over replica, and missing replica. So as we discussed, that second data node is down. When second data node was down, then replica was available with the data node 3. DataNode 3 and DataNode 100. DataNode 100. Then it was under replica because by default it should have 3. Then it was under. Then NameNode realized that okay, I am not getting heartbeat from DataNode 2. It is down or it is failed. Let me maintain that. So it maintained. It maintained and make one more copy with. It was already with DataNode 3 and DataNode 100. It made one more copy with DataNode 4. Now this is maintained completely fine. In the meantime, DataNode 2 was down, but it came up maybe after 1 hour or it got maintained. In that case, now it is having DataNode 2 also available. Okay, this is also up. 3 also, 100 also, and NameNode has created one more to make sure that I am having the 3 replica. Now it is over replica. So in the next phase, when NameNode, because NameNode is managing all the things, it is watching, monitoring, managing. So later it will delete, it will again maintain the 3, but for the time being, it is having 4 replica. So this is over replica. And missing replica is having different concept. Missing replica is not under replica. Under replica is different and missing replica is different. Missing replica, okay, now I will again come to Naresh itself. Naresh, what is missing replica? You explained very well about the under replica and over replica and all.
Missing, correct me if I'm wrong, I may be wrong. So
Yes.
missing replica is someone like NameNode. We have all the details about the data nodes. So something is missing in the node name itself about the data node.
Not actually. So the thing is, let's say in our HDFS, missing replica occurs when the number of available replica of a block falls below the configured replication factor, and this may lead to the data loss if not addressed. And the thing is, let's say we are having node failure or under replication and disk failure and all. So at high level, I can say. Let's say you are having 3 data, two node cluster, okay, and you are having 3 replica by default, and it understand that it needs to maintain the 3 replica, but it is not having the space. Assume that can be a condition, right?
Okay.
No, are you getting my point?
Yeah.
You are not getting. Okay, so let's say 3 replicas were there. 1 replica got removed or failed. That is one thing where we are getting under replica, right? In that case also 1 replica is missed. That is missing replica. Second thing is, let's say this is trying to maintain 3 replica, but you have availability of nodes and that node is not having capacity to keep that replica. That means, let's say memory full. That can be a condition, right?
Right.
So it is understanding that it has to take, but it is not able to maintain that because of memory and all. So in that case also this is missing replica. So if you check the system, this will be showing okay, I have 3 replica, but first replica is over the data node 1, second replica is data node through 2, but third replica this is not getting the space, or maybe some networking issue. So that kind of conditions can be for the missing replica. So you can say that this is mostly occurring when the desired replication factor for the file or the block is not meeting the condition. This can happen due to several reasons like node failures or network issue or the removal of the data nodes. It can be. So in that case, we can say, okay, this is the missing replica. So that is bit different from the under replica. But again, if you want, you can relate that as well. That will be. So we have let's say always have more data nodes than required to maintain the healthy replication factor, then that is fine. But if you have not sufficient data node, then maybe there can be a condition where this is not able to maintain all the replica. It knows that I need to maintain 3, but it is not having the space to maintain 3. In that case, this is again missing replica. One replica is missing because of availability issue. Okay, so that is the thing. So you can have under missing and over. Again, when you will start with the HDFS exercise, you will be good to verify that. Here you we have only one node cluster in the cloud era. You have one data node and one name node, and maybe you will not be able to see all the things as the real time picture because of one node. But the concept is same. Whenever you will be having the actual cluster of like let's say 10 nodes or 20 nodes, whatever, there the this kind of verification you can do by running the command. Okay, so here what you I was trying to explain about cluster, where we have name node, we have data node, we have secondary name node. Name node is the master, data nodes are slave. Name node is maintaining all the metadata details. Data node is storing the actual data. We have secondary name node that we call passive name node, that is for backup of each other, because as data node get down, name node also can get down. In that case, how cluster will get maintained? So name node and secondary name node, let's say this name node is connecting with data node. It is getting heartbeat on each 3 seconds. Then after each 10 interval, like 30 seconds, this is making sure that okay, this is down because I did not get the details, means a heartbeat I am not getting. So this is good to decide. And they are transferring the data between each other, all the details for the data. That is checkpoint details it is capturing. So whatever this is capturing with some interval, this is sharing the data with the secondary name node also. Let's say that can be 1 hour or 30 minutes, whatever configuration you have did. Okay, most probably it will be kind of 1 hour. Previously it was 6 hours. So you can set up the time whatever you are looking for, so that with that frequency these will be sharing the data between them. And in any case, if this is down, then this will be up and it will be play the role of main name node, means active name node. So always one will be active and one will be passive. So like that cluster will get maintained. Okay, whenever you are submitting the data, then your actual data will be splitted into the n number with depending upon block size. Always files will be splitted based upon block size only, but you can again set up the size if you want. And for each part, how many parts got after split, it will be having the replica, and those replica will get stored with the different nodes. Maybe 2 copies can be over the same node, but 1 copy mandatorily will be on the different node to make sure that if the node is down, then it can be recovered from the different node. Okay, so this is the concept. Now here one more question comes in the real time, either in the interview or maybe not interview, then this is a real time issue which you need to think about. A small file issue. Have anyone heard about it, or have you got any issue related to that? A small file? No?
No, no.
Okay. So see, for this small file issue, what happens? This service is mainly um, good for big files. Why for big files? You just assume. We are saying that whatever file you are trying to submit, let's say 1 GB file, it is creating the chunks, and each chunks are going to be stored with a different data node, and then that part is going to be maintained with the name node, that metadata details. We have one node only, right? One name node for the active and one is for passive. And you have n number of data node. Today you have 100. Tomorrow I can have 150 as well. Maybe I did the scaling, horizontally scaling, and I added some nodes. So this can be added. But these you are not going to make a 4 name node and 5 name node. No. So what is the main thing? Main thing is this is for actual data storage and this is only for the metadata storage. So we should always make sure that this is having less load for the data volume, and this should be having actual load. So actual load in the sense, let's say 1 GB file. So if 1 GB file you are going to store here, that should be NameNode should not have 1 GB of the data load, right? It should be having the meta details can be up 1 KB, 2 KB, something like that about the file. What is the data? Now assume that this 1 GB file had the 9 parts. For 9 parts, this is going to maintain 9 metadata details, right? Metadata details. Just I am assuming that one metadata details was for 1 KB. Then it is completely 9 KB. Just it is a assumption. Don't take it in the real time. Size can be varied. I am taking that, okay? 9 KB. 1 KB for 1 metadata details. So it is having 9 KB. So actual 1 GB file got stored with the data node and your name node is having the load for the 9 KB. That is okay. Now you assume that your 1 GB file got splitted into multiple parts. Not at the storage time, at the processing time. I will give you the example for that. So I'll take the example right now only. Let's say you have built up a data pipeline. That pipeline is working with the real time and your pipeline is integrated with some website where users are visiting. Let's assume that it is 7 a.m. early morning. 7 a.m. early morning, only 2 customer visit happen. Okay. Only 2 customer. And again 7:15. There is only 1 customer. Only 1 customer. Again 9 a.m. There are 100 customer. Again 9:30. There are again 12 customer only. You can see the differences in the size. Now if that is your real time data, if your service is running continuously for 24/7, what will happen? For the 7 a.m. this will be getting only 2 records, and for that 2 records this will be processing and it will be saving the output. For 1 customer also it will be doing the same, and for 100 customer or 1000 customer also this will be doing the same, right? So if whenever it is processing with the 100 and 1000 customer, then it is fine because maybe my data will be around 200 MB. That is meeting the criteria. But meeting the criteria in the sense, this is going to create 2 partitions, 1 chunk for 128 MB and remaining will be 1 part. But you assume that for this 1 customer and 2 customer, what will happen? This is going to create file for 1 KB to 1 MB like that, right? So for these small data sets, in that case, at the end of the day, if you will go to your output folder, you will be seeing that, okay, thousand and lakhs of data has been created. Means as per the timing and all, how much time this data consumption happened and how much data it had. Let's say every minute or every second, this is getting some data, but always it is getting 1, 2, 3, 4 like that only. Sometimes this is getting 100,000 and all. So whenever it is getting 100,000 and all, it's fine. But whenever it got very small number for the customers, that time it had processed very small files. So just assume that the 1 GB finally at the end of the day, let's say 7 p.m. 7 p.m. you are going to track the monitor this data. What happened with the today's processing? So you get that, okay. Today total 1 lakh records has been processed. Okay, processed record. Processed records, but out of that you have got, let's say 2000 files. Out of 2000 files, 20 files are there, 20 or let's say 40 files, which is with the good size, with average size, with average size. Remaining are all are in KB and MB with the small size, 1 MB, 2 MB, 1 KB, 2 KB, 50 KB like that. That is the issue. Why issue? Because For 1 GB, for 128 MB also, standard size is, let's say, 128 MB block size. And my file has been created with a small also, so 1 KB also, one block, and one part is kind of 2 KB, again 1 MB. So for 128 MB block size also, this is maintaining the metadata, and the metadata size is let's say 5 KB. Okay, and for this 1 KB also, metadata will be 5 KB only. You are agree with me? How this will be 5 KB?
Because it is not saving the data, it is saving the metadata of the file.
Right.
I am not
So
sure.
correct. So either this actual size is 1 KB, but metadata details will be same, like what is the name of the file and what is the replica, what is the block. This is going to save the information, and that information itself is coming with the 5 KB. For 2 KB, 1 MB, 1 KB also, this is going to take the same amount of the namespace. So what will happen at the end? Again, this is going to be same. At the end of the day, you will be find that this metadata is taking more space, and this volume is more than your actual data. Like your actual data is, let's say, 1 GB at the end of the day, and your metadata details is also ending with the 1 GB, or maybe sometimes 2 GB. It can be more as well, because of this small file size issue. And if your actual data is more, that is not an issue, because you have n number of data node that can be scaled up. That is meant for actual data storage. They are having more capacity to store, and the name node is not meant for actual data storage. That is for metadata only. That configuration is not like data node. That is not having that much availability. So if you will take the space like this, like that, your metadata is generating and metadata size is more than actual data, then that is going to be an issue, right? Maybe for data node 1 also, one only, your name node got full. There can be a condition. So this will be a headache, you can say, for the name node. Because this should, if you have less file, but so big, this big data, any platform, it is good for less number of file but good volume. It is not good for more number of file and a small volume, less volume, because less volume means your actual data storage will not happen properly, and it is going to again like 128 MB in the block size, and you are occupying only 1 MB. Then remaining 127 MB is kind of message. It is not going to be huge. It will be always unoccupied. That is one issue. And second thing is, for that small files, NameNode will be having issue to maintain the replica and all, that many times with that many replica and all. That is the thing. So if you have, let's say you have 1 GB file, and 1 GB file is having 4 parts with 250 sorry, 128 and 256, with 256 MB, you have 4 parts. Then NameNode is going to maintain only 4 metadata, like for metadata. For this 1 GB itself, if you have 100 parts, then this is going to maintain 100 metadata. This is not good, because 100 metadata means this is going to take more space, more workload for the name node also. So this will make down your name node performance and all. Again, this will be, your name node will be full at the early, and this is again creating one issue. So we should always make sure that our file size is good, and less number of files with good volume. That will be better for each and everything, for storage also, processing also, all that. At the single line, you can say your data node and name node both will be healthy. If you are ending with the small size and n number of file, more number of files, then that is not a good practice, and that is going to create issue for the name node. Your cluster will be having issue, and your name node will be slow down. It will be having memory issue. Multiple kind of challenges will be there. So this is always recommended that go with the good file size, not with the small file size. But sometimes this is not under our control. So see, the thing is, you can have the point. Okay, if you have got any issue, of course, this small file issue you can mention in your point that I have, because this is a real time issue. This can be. Now, what is the standard practice? As a standard practice, we should have good number of means your data volume should be good, file size should be good, and we should try to maintain the less number of parts, less number of chunks. Then rest replica will happen, less maintenance, metadata maintenance will happen. We should avoid n number of parts with a small file. That is going to create the issue. Now here, if we see about this example, this real time example where customer visits are happening, and accordingly this is processing the data and capturing the data. Let's say you have a data pipeline. In that data pipeline, our data pipeline is configured with the, let's say you are having a website. That website data is getting directly ingested to your Kafka topic. From Kafka topic, we are running a Spark application that is processing the entire data, and then it is loading that data to our Hadoop HDFS final output. We do not have control, right? Because we are getting to customer only. How we can increase the size or increase the file size or increase the number of customer? We can't. We are getting two customer only, so we have to process. We are getting one customer only, we have to process. We can't avoid. Then you have to think how I can take this challenge. You have multiple options. One option is, okay, you enable your system to wait for at least file size should be 100 MB or customer number of customers should be 100. Then only my Spark application will start running. Otherwise, it will wait until it has the 100 customer information. That is one thing. Either you take care for that level, or you enable your Spark to, okay, as soon as data is coming, let's process, keep on processing with one customer or two customer. That is not an issue. But at the end of the day, have one automation script. That automation script will be checking the entire directory, and it will be checking the file size. If any file size is not means if any file size is less than the block size, then file compaction means merge the file. Let's say you got 1,000 files at the end of the day, and that those are 1 KB, 1 MB, 1.5 MB and all. Then again take up all the files and rearrange with the in, let's say 10 numbers or 20 numbers, or you can say okay 128 size MB is the standard size. Then according to 128 MB, how many files can get generated? Accordingly, you get that many output files. So either you can handle at the processing time itself or the waiting state, that wait for this condition. If you do not like to go for that condition, then at the end of the day, of course, you should do something that will be making sure that you are not ending with n number of small files. At the processing time, it is storing small files, that is okay. That is for time being, temporarily you can say. But at the end of the day or whenever you are planning for the project, make sure that you are maintaining that to get the file merge and have a standard size. So your name node will not having any bad impact. Okay. So this is one of the challenge. So this server and cluster is made for good size, big files with a small number of parts, not for small files. Small files means your cluster impact will be happening for the NameNode side, because it will be having more load, and a NameNode will also it should be having less workload, uh, even mostly for the data storage comparing to DataNode. DataNode is meant for actual storage. So let give all the data related issue. When data related is in the sense all the actual storage, more data storage and all, let it happen with the DataNode only. Don't enable NameNode to take more data and all. That data generation, metadata generation should be minimum and less volume of the data and all. Okay. Any question here?
Anamika, just one question. If you are considering about the small file size issue, then why not we are increasing the size of the data blocks? I mean, from 128 MB to we can increase the file size to
Yes.
256.
Yes. So what I gave the problem, my problem was you are running a job. Okay. Your job is running with let's say as I said in the example, you are having a website and you have the integration that website data, let's say that's the real time data customers are visiting, and that customers visit data is coming to your pipeline immediately. Okay, your Kafka got that two records, two customer detail, then your Spark processed that two customers data, and a final output got stored in the output. How it will meet that 128 MB or 256 MB file size? Let's assume that you have set up the 256 MB by default file size, but that will be working only if you are getting a big file. Let's say you got 2 GB data from the source, then your server will maintain 256 MB by default size, whatever you have provided. It will be creating that chunks that is meeting to that block size. But if small data is coming from source itself, then your system will not able to manage, right? Getting my point?
If it is coming, yeah. But if it is coming less volume of data, then
Huh?
it will contain only that much only. So there should not be any issues, right?
Yeah, data node is not having any issue. But my point is for 1 KB data also, your name node will maintain metadata, correct?
Yes.
And again one MB data you got, again it will maintain one metadata. That means for 100 MB data, if you are getting 50 times like 2 MB 2 MB 2 MB, then name node is maintaining 50 times metadata, correct?
Yes.
If you will check the volume, there can be a condition that name node is having more volume comparing to data node. Means data node got 100 MB and maybe name node metadata details got 150 MB, 200 MB like that. So that will be more than the actual data. And this is meant for actual data should be more and name metadata details should be very less. It should be in KB and MB for the GBs of the data. It should not be equal or there should not be the ratio like 1/3 or 1/4 because you have only one name node and that is having the configuration maybe of 1 terabyte or 5 terabyte or maybe 100 terabyte, and you are having 100 data nodes. You can have 1,000 data nodes based upon the workload, and they are processing with the data. So you can't compare your 1,000 data nodes with one name node, right? So your actual data should be more and that should be stored with the data node. Name node is not meant for um, storing the actual data size. This is meant for a small file information. File information should be less. And with the small file, that many information will be generated and that will be creating the issue. That's only the problem.
Okay, so in a real-time project, what is the ideal block size? It is
It will be most probably 128 MB. But I
oh,
have seen in my projects and all that is set up with 256 MB.
okay.
So ideally, on average, it will be coming with 128 MB most of the organizations, and the few have set up with 256 MB also. And we have the option as a developer, even if you are, I'm not talking about that is small file issue. On average, if you want, you can go with the 256 MB for your particular files and all. But this is small file issue as we are not having control while processing and all. So we think about the last step, that once the all the processing is done, then if I can revise and we can resume to the actual size, we can convert those small files with the average size, then we can overcome from the issue.
You mean the comparison?
Right.
Oh,
Okay. Then let me go here. And I believe that you have understanding with NameNode, secondary NameNode, and DataNode. If no, you can discuss anytime, you can ask me. Okay, so NameNode, this is the master server that is managing the file system, namespace, and regulates access to files by clients. It maintains the file system's tree and metadata for all the files and directories in the tree. For the data nodes, these are the worker nodes that stores the actual data. Data nodes perform read and write requests from the file system's client. They also perform block creation, deletion, replication upon the instruction from the name node. Because name node knows each and everything about the data because it is uh, storing all the information with its metadata. So name node will instruct, okay, the data node 2 is down, make one more replica. And data node 4 is having the availability. So replica, make another replica there. So based upon the instruction from the name node, data node will be working out. Then in HDFS architecture, you are having file storage where files are split into the blocks. Default is 128 MB and these blocks are stored across the cluster of machines. Each block is replicated. Default is 3 times. Again, it is configurable to ensure the fault tolerance. So if anyone is down or if anyone is missed, then it can be recovered from the another copy. Then file system namespace. The name node maintains the hierarchy of files and directories according to its availability in the data nodes, and it records changes such as file creation, deletion, renaming, whenever whatever happened, all the details will be available with the namespace. And data replication. So to ensure reliability, each block of data is replicated across multiple data nodes. If a data node fails, then data can still be retrieved from the other nodes. So this is for the storage part, how data is getting stored. Once your data storage is done, then your processing part will be in the picture. How it is getting processed? We have map reduce option. Okay. So for map reduce option, it is having map page, it is having reduce page like we discussed yesterday as well. So here map reduce is a programming model for processing large data sets with a parallel distributed algorithm on a cluster. Key components we are having job tracker and task tracker. Like in the storage part, you are having master and slave. Master is the name node, slave is the data node. For processing wise also, you have master and slave architecture. Job tracker is the master and task tracker is the slave. Job tracker is saying, hey, this is what to process. This is how to process. Task tracker is following the job tracker, but they are working along with NameNode and DataNode only. They are having the physical storage, physical nodes and all. They are not having the same. They means they are not having different cluster and all. They are also working with the same cluster. So this job tracker will be associated with NameNode. You can just assume because this is also a master. They can be over the same node or maybe different machines. Task tracker will be associated with the data node where let's say you have a 1 GB file and you have 9 parts to be processed. 9 parts are stored with the 9 different data node. Storage part is done. Now how it will process? For processing it needs map reduce. So for map reduce it is having the slab that is task tracker. Task tracker will be associated with data node that will process that data which is stored to that data node. Okay, so for processing we have the task tracker. So this is again having master slave architecture. Okay, where this job tracker, this was the master node for Hadoop 1 previous version that managed the jobs and resources in the cluster. In Hadoop 2, job tracker functionalities are divided into resource manager and application master. Bit architecture, anyways, architecture will always be having some changes with the upgrade and the latest version. Always there will be some enhancement. Then task tracker. These were the worker nodes in the Hadoop previous version that performed the task assigned by the job tracker. In Hadoop 2 or the later version, task trackers are replaced by the node managers. Okay, like resource managers and node managers. You have application master that is managing the entire application master, in the sense that is how NameNode is a master, like job tracker is now playing the role with the name of application master, that okay, I am the master and I am going to process the data. Then it is having multiple slabs, let's say node managers. So let's say 10 nodes means 10 data nodes are there. On each 10 data nodes, 10 node managers are assigned. Then it will say, okay, this is the 1 GB file you have to process. Then these node managers are going to process the file which is stored over the data nodes. This is how it is going to work. Now you have Yarn. Yarn is the resource manager. You have the data, you have to process the data, but who will instruct, who will manage, who is going to communicate? That is Yarn. Okay. You can have multiple options for this. Again, you have Mesos, you have Kubernetes, you have Yarn, but Yarn is very popular. Uh, Anyways, right now Kubernetes is also going with multiple projects. You may see that Docker and Kubernetes deployments are happening, right? So this Yarn, if you are having any Hadoop or Spark like application, then you will be getting this Yarn in a very, means you can say lots of projects will be running with the Yarn at the majority. But Kubernetes also, if anyone is having the setup, the entire setup with the containerized applications and all, then that is running with the Kubernetes, and maybe some other resource manager can be. So with this Hadoop, Yarn is introduced. Means before in the previous version of Hadoop, it was not. It was introduced with the Hadoop 2, and with the later version still it is there. So Yarn is introduced, which splits the responsibilities of resources, and it is mainly for the resource management and job scheduling, monitoring into the separate domain. Because okay, this job is there, this job is running, this job is running with multiple nodes. Someone should be there who is keep an eye and managing the resources, taking the responsibility of each and everything for the assignment to creating the applications, JVMs, child JVMs for the processing. Then once processing is done, then maintaining the history, then killing the JVMs to make the resources free. So these kind of responsibilities are coming with the Yarn, which is known as the resource manager. So here it is having the part as resource manager, the global resource manager that arbitrate all the available cluster resources. Then node manager. This runs on each node and is responsible for managing the node's resources, monitoring the health of the node, and reporting to the resource manager. And then application master. So manage the life cycle of the application running on the Yarn, and each application has its own application master. Each application, in the sense, let's say you are running application ABC. I am running application XYZ. Of course, both are separate, both are different, both can have same source or both can have different source. There is no nothing common. There can be something common, there can be nothing common. It can be completely distinct and different. In that case, my job is running with my own setup, your job is running with your own setup in all the conditions. Okay, it will be never like my job is also running with the same application master and your job is also running with the same. No, if I am submitting a job, that will be assigned with the another application master. You are submitting a job, that will always assigned with the application another application master, because both are having different life cycle. Both will be managing accordingly, and maybe your job can take 1 minute, my job can take 5 minutes to process with its differentiations and all. So for each application, whatever we are submitting, they will be having assignment with the different application master, and that will be completing the life cycle. Then in Hadoop ecosystem, we have multiple tools. As of now, Pig is there, which was very popular a few years back, but now it is not. So we have mainly, so beyond the core component, Hadoop has a rich ecosystem tools to framework that is supporting various data processing according to the business needs and requirements. So we have Hive. Hive is very popular. Either we're working with on-premise or with the migration project or with the cloud system. You can see Hive in many projects. Let's say on-premise, mandatorily it will be. If that is the migration is having options like as it is in the source, in the on-premise, you want to migrate in the same way to avoid any rework or keeping more effort and all. So let's say your on-premise is Hive, then you want to and you have 1,000 scripts, 1,000 tables. You do not want to rework again. You simply want to move your 1 GB, 1,000 tables from on-premise to Azure. Then you can adapt a Hive also as it is. So you can avoid all the rework and all. As it was working in the on-premise, it will be working similarly in the cloud side also. Or you can adapt with few changes, or you can create start with fresh, because in Hadoop we have in Azure we have HD insights for the Hadoop supports. In AWS we have EMR services where you can create MapReduce cluster, and you can go with Hive, Hadoop and all. We have the option. So this Hive is very popular either in on-premise or it can be with the cloud system. This Pig was a high-level platform for creating MapReduce program, and this was faster than Hive when it was in use, when Spark was not in the market. But when Spark came, it it got disappear. It is there. Maybe some companies are using, but not in use. So we can avoid this for now. Then we have HBase. HBase is a Hadoop inbuilt NoSQL database. If you have the requirement in Hadoop for NoSQL database, of course you can go with it. If you are not having option for any third party, because third party means you have to pay for the license and all, if that is not open source. And if you have Hadoop setup, then HBase is free for you. You can use that. So this is NoSQL database available in the Hadoop that is runs on top of HDFS. And you have Scoop. Scoop is for importing and exporting the data. Let's say you have data in database. You want to move that data from database to HDFS or Hive. You can use Scoop. You have data in HDFS. You want to move that data to MySQL. You can. You using JDBC connector. You can connect. You means for import and export. You can use Scoop. And one thing is there in Hadoop side or any platform. Either you talk about cloud also. Where is the storage capacity? Either you use Hive or Pig or HBase or Scoop. It is not having a storage capacity. Storage capacity is HDFS only. Wherever you are working, actual data will be stored over the S3. This HDFS. If you are working with the AWS, then most of the services are going to use S3. If you are working with Azure, most of the services are going to use your ADLS. So these are the file system where you have a platform. Wherever you are working, which tool you are using, that is okay, but finally data storage will be happening to your file system only. Okay, and like that you have Flume. Then data and you can use it for like data ingestion, data ingested into HDFS from various sources like the tools with the scope and custom scripts, Flume and all. Then data is stored in HDFS, which will be splitting into the blocks, maintaining the replica with the data nodes and all. Then data processing, where it is processing with the MapReduce and Yarn, and jobs are submitted, and resource managers allocating the resources and scheduling the tasks. Then access and analysis, where we have tools like Hive and all, which you are using for querying and analyzing to process the data. Then data export and import. You can do processing data can be exported to other system as well, or consumed by the downstream application where you can build up the data pipeline and all to complete your project and complete workflow. So that is the thing about Hadoop. I hope it is fine. If you have anything, any question, please let me know. Tomorrow we will be having a few more discussion about it, and then we will start our practical thing with the HDFS and all. All good? Or any challenge, any issue?
One question, Anamika. If
Yes.
ultimately the data is getting stored in HDFS, then
Mhm.
why we need Hive then?
Because let's say HDFS is storing the data, but you want to convert that data into the tabular format for your analysis. How you will do? You need some tabular structure, right? So in a
Okay.
Hive, you can create the schema and then you can your data will be getting converted into the tabular structure. You can query the data. You can perform the analysis and all.
Okay, just for the tabular purpose, so we are using Hive.
Correct, for your analysis purpose. But your file will be, let's say you were creating the table and you created the table with five columns, five schema. Then in HDFS directory, your data will be stored with that file schema, file columns. Whatever logic we applied, whatever output it is generating, accordingly data will be stored. It will be processed and it will be stored.
Okay. But the data will be stored in HDFS only.
Correct. We will see that practically when we are starting with this.
Okay. And when you say you are using Scoop to export the data, so in which scenario we are exporting the data? Because data
Okay,
is
so
getting
let's
stored in
say you
HDFS.
have Teradata. Just assume that you have Teradata and that Teradata is having some 5 years data. Now you are planning to migrate your data to Hadoop system or maybe your any platform wherever you are working. You have to migrate to Hadoop. How you will migrate? How you will connect your Teradata with your HDFS or Hive? You need a service, right? You need a tool.
Yes.
So this is inbuilt tool which understand the JDBC connectivity and very simple syntaxes are there. You can just write a single line means very small syntax, simple syntaxes are there. You can write and you can connect with your any database JDBC with the JDBC connectivity and you can import and export. So in historical data processing, migration and all scope is required. Okay, fine then. I hope all good. If you have anything, then we can discuss anytime, not an issue. And never ever hesitate because here we are for learning only, right? Learning means nothing big, nothing is small, everything is okay. We are here to discuss only. So don't keep any confusion with you. Let's discuss that openly. Okay, fine then. Let's meet tomorrow and see if you have any question, just let me know.
Sure, Anamika. Thank you
Okay,
for the
fine.
session.
Have
Yeah,
a good day. Bye.
yeah. Thanks all.